So, back at it with section 3.5. This is about graphing rational functions. So for this first video, we're just going to talk a little bit about what the heck a rational function is. And we're going to outline a strategy for graphing. We're going to work a little bit sort of backwards from how the book lays it out. We're going to sort of start with our strategy, and then we'll fill in with the next videos what some of these new concepts are and what we're going to need to find out. So, first and foremost, what is a rational function? It's essentially a fraction made of polynomials. So, meaning it's sort of a function with a numerator and a denominator, and each of those two things individually is a polynomial. So, our sort of general form would be f of x. We'll use p and q. Would be sort of p of x over q of x, where p and q are polynomials. So we're just making stacks of polynomials. This is good. The exponents will be whole numbers, right? Positive whole numbers. The exponents will be the nicest possible versions of themselves. The sort of obvious, like, new information here is anytime we get any kind of fraction, right? A rational to us is sort of a math word that means fraction. And so anytime we get a fraction, one of the main things we're going to need to sort of deal with is getting a zero on the bottom. So we need to deal with points where q of x, which is our denominator, is equal to 0, right? That's going to give us two potential outcomes. So this is either gives what we're going to call a vertical asymptote. So we're going to go through all of that and what the heck that means in a separate video because it takes a minute to talk through. Or it's going to give us essentially just like sort of a single hole or like gap in the function. First and foremost, for sure, it's sort of a does not exist or an undefined value individually. So that 100% is always going to be true. The question is it something that's sort of like a catastrophic failure, which is going to give us this sort of asymptote behavior, which has this sort of infinite sort of shooting off into space kind of look to it? Or is it something that's maybe a little bit less dramatic and we simply just get a tiny hole in the graph and otherwise it kind of just behaves normally? We're going to see a lot more asymptotes in this section generally, but in theory you could have either. Let's lay out a strategy, and we'll kind of check a couple things off on the strategy that are fairly short that we don't really need too much more explanation for. And then in the next videos, we'll obviously spend more time dealing with the new things. So, strategy for graphing. I'm essentially leaning on the setup and the strategy that the book lays out. So this is for, right, generic rational function f of x that's equal to p of x over q of x. So that's our form. So step one, and I'm sort of going in the book order here. If I was sort of making this up totally off the top of my head, I probably would switch the order on some of these things. Step number one is do a symmetry check. right? So that's where we see is f of negative x equal to the original or to the negative version of the original. If we sub in a negative x, does it sort of flip all of the negative signs and we sort of come back to like a negative version of the whole thing, or does it sort of absorb all the negatives and we end up essentially at a version back where we started? This is a little bit more tricky and involved than just having individual polynomials, because you have sort of a top and a bottom polynomial where both of these things are happening. So in theory, you could have something where both the top and the bottom, all of the signs, positive and negative, totally flip. But if that happens, then you in theory would have negative versions of each of these over top of each other, and you'd end up back with a positive version, sort of back at the original. We'll do a couple examples at the end of the videos for this section where we run through all these steps and make some graphs. For the most part, I'm not going to do a separate symmetry video here. We'll sort of just acknowledge, in theory, we're subbing in negative x, and we're just trying to track and see if it flips all of the signs, or if it doesn't. Again, typically, probably the most common thing is that it's not symmetric. It just sort of is a mixture of some things change and some things don't. But we'll definitely look at going through that process when we get to the actual graphs here at the end. The second thing, another sort of short one, is find the y-intercept. That one is very fast, right? So we're just going to simply calculate f of 0, right? So the y-intercept is the value we get when x equals 0. So all we do is just sub in x equals 0, just sub it into here, and just see what we end up with. If it ends up being something that makes the denominator 0, then obviously that's going to sort of fall into this asymptote or sort of whole gap category. Again, that's a whole separate step. If we just get a number, then great, that's cool. We're just going to get that as sort of one point that we can use to make our graph. Step number 3. This is going to be find the x-intercepts. What we call the zeros in our polynomial section in 3.2. And what that's going to amount to is set your denominator equal to 0 and solve for x, right? So that's going to mean our sort of p of x, the polynomial up on top, right? We're just going to set that equal to 0 by itself and solve for the x. There's a little bit of a hierarchy here. In theory, right, we're going to sort of ignore the denominator when we do that. And we're just going to do the typical, right, factor and sort of solve for the x. Kind of moves. It's really the same kind of thing we did in 3.2 and the same thing we were doing sort of earlier in the book. So we'll have to do some sort of double check that we're not also getting an x value that makes the bottom 0. This sort of ties into our fourth step, so maybe I'll sort of put that down here too. These are kind of linked. So step number 4 is going to be find any of these vertical asymptotes. So again, there could be one, there could be none, there could be more than one. There's all sorts of different possibilities here. So in general, right, this is going to be where, oh, I said denominator here. This, of course, should have been the numerator. My bad. We need to set the top equal to 0 to find the x-intercepts. The denominator, right, on the bottom is going to give us these asymptotes, right? So that is where q of x is 0. That's the short version. We're going to, again, talk about this in the whole thing because this is a new concept. This could also, in theory, be a place where we just get like a hole or a gap. We have to do a little bit of a double check there. I'm going to sort of just tie all those things together. Generally, we're going to be looking for vertical asymptotes. And again, there's a relationship between sort of steps 3 and 4. The sort of cleanest version is you just get different points for each of these. The idea is, your x-intercepts will sort of come from the top, provided they're not also making the bottom equal to 0. And then a similar kind of thing, your vertical asymptotes will come by solving the bottom equal to 0, provided it doesn't also make the top equal to 0. These holes and gaps, so these are going to happen where, I'll spoil it a little bit, both the top and the bottom are equal to 0 with the same coordinate. So if you have a situation where both the top and the bottom are equal to 0 at the same time, that's still going to be undefined, but it's going to give us this sort of hole or gap in the function. It's not going to give us this vertical asymptote. Step number 5 is going to be to check for horizontal asymptotes. So this is a whole nother new aspect I didn't even mention before. So that's obviously also going to be a whole nother video to sort of go into that explanation in detail. This is essentially a version of end behavior for our rational functions. The idea, instead of necessarily just going up or down to positive or negative infinity, there are a few more options. There are a few more things that could happen. So we're going to use these horizontal asymptotes or potentially something else. We're going to have a whole process there. There's sort of a 3-case situation. We'll obviously go through those. That's going to be a separate video. Once we've done that, we're going to plot at least one value between any x-intercepts and vertical asymptotes. So I've kind of said, right, that the idea is we're trying to set up a way to make some of these graphs without necessarily just making a table and doing sort of a brute force method to just like plot enough points that we can outline it. That's still true. Obviously, this is a longer process than the 3.2. It's a more complicated setup, so that's in some sense to be expected. And part of it still is going to be plotting some points. Essentially what we need to know is sort of between all of these like action points, is the graph going to be like positive or negative? And then that's going to allow us to, once we have all that information, graph that function. So our final step is just like make a graph, buddy. You've got all this other stuff laid out. That's, a whole pile of information, and that should be enough. But again, just like in 3.2, we really need to be careful and sort of put it all together in a really organized way. So we'll do videos talking about our vertical asymptotes and sort of what that means. We'll do horizontal asymptotes, and then we'll sort of do at least 2 different videos running through examples of all this stuff together. So there you go. That's the plan for section 3.5.